Hey guys, in this video I'm going to show you how to graph sine and cosine functions. It's a method I use to teach my students and I've called it SPAMI. What SPAMI stands for is the 5 pieces of information you need to write down before you start sketching sine or cosine graphs. I'll quickly go through and summarize how to get these information, and then we'll get into examples of how to sketch graphs. The S stands for the starting point. This is the x-coordinate where the graph will start from. The P stands for the period, A is for amplitude, M is for the midline or mid position, and I is for the interval. The interval is the distance or space between each quadrant. Whenever you're asked to sketch a sine or a cosine function, then it's going to be written in the general form y is equal to some constant a times the function sine of n times x minus h and then plus k, or y is equal to the constant a times cos of n times x minus h plus k. To find the starting point, what you need to do is let whatever's inside the brackets of the sine or cosine function equal 0 and then solve for x. And so in the general form we would let this equal 0 and solve for x. And so n times x minus h is equal to 0. Solving for x, x is going to equal h. This means we start to sketch the graph when x is equal to h. The period of a sine or a cosine function is equal to 2 pi over the value of n. The amplitude is the constant in front of the sine or cosine function, and this is going to be a. Now the amplitude is always positive. If we had a negative number, that just means that the graph is going to be reflected. The midline, this is the constant that's added or subtracted to the function, and so this is going to equal y is equal to k. And the interval, this is the space between the 4 quadrants, and the way we work this out is we divide whatever the period is by 4. So how does this all fit in graphically? An important thing to know when you're graphing sine and cosine functions is that we always start with drawing the midline first. And so looking at the basic sine function, there's no constant added to sine x, and so the midline is going to be the line y is equal to 0, and we show this by drawing a dashed line. The amplitude is 1, and so from the midline the maximum value is going to be 1 and the minimum value is going to be -1. The starting point is when x is equal to 0. The period is going to be at this point. And now we need to mark the 4 intervals, and we do this by dividing the period by 4. And so dividing the period by 4, we're going to get 4 intervals. Here is going to be half of the period. Here at this point is going to be a quarter of the period, and at this point we're going to have 3/4 of the period. For a positive sine graph, we start at the midline, we go up to the maximum, we then come back down to the midline, go to the minimum, and then come back to the midline. Looking at the graph of the basic cos function, the midline is going to be the line y is equal to 0. The amplitude is 1, and so from the midline the maximum value is going to be 1 and the minimum value is going to be -1. The starting point is when x is equal to 0. The period is going to be at this point. If we divide the period into 4, we're going to get 4 intervals. And so this point is going to be half the period, this point is going to be a quarter of the period, and this is going to be 3/4 of the period. For a positive cos graph, we start at the maximum value, then we go to the midline, then down to the minimum value, then to the midline, and then back to the maximum value. That's it for the theory part. Now let's get into some examples. Part A, y is equal to 4 sine x. So before we start sketching this graph, we need to write down the 5 pieces of information. And so we want the starting point. For the starting point, we let whatever's inside the brackets equal 0 and then solve for x. And so this is just going to be x is equal to 0. Then we want p, the period. The period of this is just going to be 2 pi on 1, which is just 2 pi. Then we want the amplitude. The amplitude is going to be 4. Then we want the midline. The midline is going to be the line y is equal to 0 since there's no constant added to the sine function. And the last thing we need is the interval. For the interval, we divide the period, which is 2 pi, by 4. And so simplifying this, this is going to equal pi on 2. And so the space between each interval is going to be pi on 2 units. Now that we've written down this information, on the axis we start by drawing the midline first with a dashed line. And this is going to be the line y is equal to 0. The amplitude is 4. And so from the midline, the maximum value is going to be 4 and the minimum value is going to be negative 4. The starting point is when x is equal to 0. And then from here, we need to mark our 4 intervals. We know that the intervals are pi on 2 units apart. And so starting from 0, we go pi on 2, and then 2 pi on 2, which is the same as pi, and then 3 pi on 2, and then 4 pi on 2, which is the same as 2 pi. And that should be 1 period. For a sine function that's positive, we start at the midline, we go up to the maximum value, come back to the midline, go down to the minimum value, and then come back to the midline. And now that we have these points, we connect the dots and sketch the graph. Giving us the graph of y equals 4 sine x. Now depending on the given domain, you may need to continue the graph to the left or to the right. To do this, just add a few more intervals as you need and then follow the pattern of the graph. And so if we had to go to the left, the interval is pi on 2, and so this would be minus pi on 2 and then minus pi. Continuing to the right, we've got 2 pi and then plus pi on 2, that's 5 pi on 2. And then 6 pi on 2, which is the same as 3 pi, and then 7 pi on 2. From the origin going to the left, we will go down to the minimum value, and then back up to the midline. Continuing from the right, from 2 pi, we will go up to the maximum value, down to the midline, down to the minimum value. And now we just connect the dots. Part B, y is equal to root 2 cos 2x. For the starting point, we let whatever's inside the brackets equal 0 and then solve for x. And so if we let 2x equal 0, solving for x, x is going to be 0. And so the starting point is going to be when x is equal to 0. The period is going to be 2 pi on 2, which is equal to pi. The amplitude is going to be root 2. The midline is going to be the line y is equal to 0 since there's no constant added or subtracted to the cos function. The interval is going to be the period, which is pi divided by 4. Now that we have these information, we can start to sketch the graph. Starting with drawing the midline, this is going to be the line y is equal to 0. The amplitude is root 2. And so the maximum is going to be root 2 and the minimum value is going to be minus root 2. The starting point is 0. And now drawing our 4 intervals, the interval length are going to be pi on 4. And so starting from 0, this is going to be pi on 4, and then this is going to be 2 pi on 4, which is the same as pi on 2. This is going to be 3 pi on 4, and then this is going to be 4 pi on 4, which is the same as pi. For a positive cos value, we start at the maximum point, we come down to the midline, then we go to the minimum point, then to the midline, and then back up to the maximum. And now that we have our points, we just connect the dots and sketch the graph, giving us the graph of y equals root 2 cos 2x. Again, if you needed to continue the graph to the left or the right, just add in more intervals and follow the pattern of the graph. Part C, y is equal to minus 4 sine 3x. For the starting point, we let 3x is equal to 0 and then solve for x. And so x is going to equal 0. The period is going to be 2 pi on 3. The amplitude is going to be 4. The midline is going to be the line y is equal to 0, and the interval is going to be the period, which is 2 pi on 3, divided by 4, which is the same as multiplying by 1 on 4. Simplifying this, the 2 and the 4 will cancel out, and so this is going to equal pi on 6. And now on the axes, we'll start by sketching the midline first. This is going to be the line y is equal to 0. The amplitude is 4, and so the maximum value is going to be 4 and the minimum value is going to be 4. The starting point is when x is equal to 0. And now we mark the 4 intervals. We know that each interval has a distance of pi on 6 units. And so starting from x is equal to 0, this is going to be pi on 6, and then this is going to be 2 pi on 6. Which is the same as pi on 3, and then 3 pi on 6, and then 4 pi on 6, which is the same as 2 pi on 3, which is the period of this function. For a negative sign function, we still start at the midline, but this time we go down to the minimum value, and then back to the midline, and then up to the maximum, and then back down to the midline. Now that we have our points, all we do is just connect the dots and sketch the graph, giving us the graph of y equals minus 4 sine 3x. Part D, y is equal to 2 cos a third of x minus 1. For the starting point, we let whatever's inside the brackets equal 0 and then solve for x. And so a third of x is equal to 0, solving for x, x is going to equal 0. The period is going to be 2 pi on 1 on third, which is the same as 2 pi times 3 on 1, which is equal to 6 pi. The amplitude is going to be 2. This time, the midline is going to be the line y is equal to minus 1. And for the interval, we need to divide the period by 4. And so 6 pi, which is the period, divided by 4. If we simplify this, 2 goes into this 3 times and into this 2 times. And so the intervals are going to be 3 pi on 2 units apart. And now on the axes, we start by drawing the midline first, which is going to be the line y is equal to minus 1. The amplitude is 2, which means the maximum value from the midline is going to be 1, and the minimum value is going to be minus 3. The starting point is x is equal to 0. And now marking the 4 intervals, we know that each interval has a distance of 3 pi on 2. And so starting from 0, the first interval is going to be 3 pi on 2. And then adding another 3 pi on 2, this is going to be 6 pi on 2. And then adding another 3 pi on 2, this is going to be 9 pi on 2. And then 12 pi on 2, which is the same as 6 pi. And this is the period of this function. For a positive cos function, we start at the maximum value, above the midline. We come down to the midline, and then we go down to the minimum, and then back to the midline, and then return to the maximum. Now that we have our points, we just connect the dots and sketch the graph, giving us the graph of y equals 2 cos a third of x minus 1. Part E, y equals 2 minus sine x minus 2 pi. To find the starting point, we let whatever's inside the brackets equal 0 and then solve for x. And so x minus 2 pi is equal to 0. Solving for x, x is going to be 2 pi. And so this time our starting point is going to be when x is equal to 2 pi. The period is going to be 2 pi on n, which is just going to be 2 pi. The amplitude is going to be 1. The midline is going to be the constant that's added to the function, and this is going to be the line y is equal to 2. And for the interval, we need to divide the period by 4. And so this is going to be 2 pi divided by 4. Simplifying this, this is going to be pi on 2. And now drawing the midline, this is going to be the line y is equal to 2. The amplitude is 1, which means the maximum value from the midline is going to be 3 and the minimum value is going to be 1. The starting point this time is when x is equal to 2 pi. We know that each interval is pi on 2 distance apart. And so if we have 0 here, this will be pi on 2, this will be 2 pi on 2, this is going to be 3 pi on 2, this is going to be 4 pi on 2, which is the same as 2 pi. This will be 5 pi on 2, 6 pi on 2, and then 7 pi on 2. A sine function starts at the midline, and so when x is equal to 2 pi, which is our starting point, the sine function is going to start at the midline. Now this is a negative sine function, which means the graph is going to be reflected. And so instead of going up to the maximum, we're going to go down to the minimum. And so for the next interval, we're going to go down to the minimum. And then for the next interval, we're going to return back to the midline. And then for the next interval, we're going to go to the maximum. And going to the left-hand side, we just follow the pattern. And so we start from the midline, and then we go up to the maximum. And then come back to the midline, and then to the minimum, and then back to the midline. And now that we have our points, all we do is connect the dots and sketch the graph, giving us a graph of y equals 2 minus sine x minus 2 pi. Part F, y is equal to minus a half cos 3 times x plus pi plus 1. For the starting point, we let whatever's inside the brackets equal 0 and then solve for x. And so x plus pi is going to be 0. Solving for x, x is equal to minus pi. The period is going to be 2 pi on 3. The amplitude is going to be a half. The midline is going to be the constant that's added to this function, and so this is going to be the line y is equal to 1. And for the interval, this is going to be the period divided by 4, which is the same as the period, which is 2 pi on 3 times 1 on 4. Simplifying this, this is going to cancel out with this, and so the interval is going to be pi on 6 units apart. And now on the axis, drawing the midline, this is going to be the line y is equal to 1. The amplitude is a half, which means the maximum value from the midline is going to be 1.5 and the minimum value is going to be a half. The starting point is going to be when x is equal to minus pi. We know that each interval is equal to pi on 6 units apart. And so this is going to be minus pi on 6. This will be minus 2 pi on 6, minus 3 pi on 6, minus 4 pi on 6, minus 5 pi on 6, and then minus 6 pi on 6, which is the same as minus pi. On the right hand side, this will be pi on 6, and then 2 pi on 6, and then 3 pi on 6. For a negative cos function, we start at the minimum value. And so when x is equal to minus pi, which is the starting point, the cos function is going to be below the midline. For the next interval, we're going to go back up to the mid position. And then for the next interval, we're going to go to the maximum value. And then down to the midline, and then down to the minimum value, back to the midline, the maximum, and then the midline, and then the minimum value, and then back to the midline. All we do from here is connect the dots and sketch the graph, giving us a graph of y equals minus a half cos 3 times x plus y plus 1. And that's it for this video.